Okay, so this is going to be the Unit 1 review for your final. So you should have your Unit 1 review out, or your Unit 1 pack out, or you can refer to the email to get the electronic copy. The first problem was Bucky the Badger, and that was just something that we did to get you interested in that, into the lesson. So we will not have anything on that. Task 2, you do need to look over. And I will tell you that you will have some of these on your final. And here is what I want. You will use the fact that 13 times 17 equals 221 to find the following. You'll have something that looks similar to this. And then it will say explain why. So you will have to tell me why it is what it is. So 13 times 17 equals 222. And this is how I would suggest you do it. Always start with 13 times 17. Equals 221. And then just take these pieces and break them down. So 13 would stay the same. But to get from 17 to 1.7, you would do 17 divided by 10. Now to keep something equivalent, if I divide this side by 10, I would have to divide this number by 10. This would be the y part, and then when you get the answer, that would be the second part. So this would be sufficient for your y, and then 221 divided by 10. If you do that on the side of your paper, you would get 22.1. Most of you are going to know that if this decimal place moves 1 to the left, then this decimal place would move 1 to the left. But this is the reason why that is. Okay. Same thing with 13 times 17. If you do 13 or 130 times 17, 13 times 17 is 221. Write that down and then tell me how 13 got to 130, which would be 13 times 10 and then times 17. So that would be equivalent to 130 times 17. But if I multiply this side by 10, I would have to multiply this by 10. And then that would be one check. That would be your y. And then your answer would be 2210. Okay, so try to do your best on the rest of those to see what you can do with those statements. If you have questions, let me know. So you should have one part that gives me the why and then the answer. Task number 3, you will have one like task number 3 as well. So task number 3 tells you that Felicia, you can pause the video and read this or look on your packet. Felicia is traveling. She is traveling somewhere at 70 miles per hour. And she takes an hour and 15 minutes to drive. Her car gets 30 miles to the gallon, and it costs $3.50. It says, describe and estimate that Felicia might do in her head while driving to decide how many gallons of gas that she needs. So if she is traveling at 70 miles per hour, and she's traveling for 1 hour and 15 minutes, I think most of you know that 15 is a quarter of an hour. But if you don't, 15 minutes out of 60 minutes would reduce to 1/4. So she's essentially driving 1 1/4 hours. So if she's traveling 70 miles per hour, in 1 hour she can travel 70 miles. Plus, if you do a quarter of 70, so that would be 70 divided by 4. The closest thing you can do, like 60 divided by 4, you should know is 15. And 80 divided by 4 is 20. So somewhere in between that would be 70 divided by 4. So you could do 17.5. That would be a good estimate. So in 1 hour she would travel 70 miles, and in a quarter of an hour she could travel 17.5, which is a total of 87.5 miles. If she gets 30 miles per gallon and she's traveling about 90 miles, she would need 3 gallons of gas to get to where she's going. So that's how you would set that problem up. As long as I've seen some work like this, then I could give you full credit for part A. I want you to try to do part B. If you have questions, just let me know. All right, lesson 2. Excuse me. You will not have magic math. We will not do questions like this. Okay, but you will have something like task number 4. And if you read this, pause the video and read it. You are trying to find algebraic expressions for Abby and Renato. So Abby takes the number of miles, let's say m. So the number of miles, and she doubles it. So that would be 2 times the number of miles. And then she subtracts 20% of the result. Now, if you subtract the result is this. So 20% of the result, 2m. That would be Abby's. When you do Renato, or let me back up, doing Abby's, this is acceptable. This is exactly what it says. It subtracts 20% of the result. It is not this. It is not minus 0.2. That is only taking 0.2 of a number. This is taking 20% of this number. So that's completely different. You can also do this. She could have 2m. And then if you take 20% away, you would be maintaining 80%. So that would be an equivalent statement. Okay. Renato first divides the number of miles by 5. So Renato would do m divided by 5. And then he would multiply that result by 8. So that's Renato's. Okay, I think part B asks you to state, decide if the 2 methods give the same answer. So let's look at this. So when I say the same answer, I mean that the expressions are equivalent. So if we set those equal to each other, I want to prove to you real quickly that these are the same. If I had 2, if I had 2m minus 0.2 times 2 is 0.4, and 2 minus 0.4 would be 1.6m. If you do 0.8 times 2, you also get 1.6m. So both of these would reduce to 1.6m because this is multiplication, and then m and m, you could put those together. So I have to prove that Abby's, which is 1.6m, equals, or maybe it doesn't equal, m over 5 times 8. Well, since this is already one number, I would change this to be 8/5 m. And then there's a couple of ways you can do this. You can change this to a fraction, or you can change this to a decimal. I would probably do a little bit of both. Like this right here is 1 6/10. Sorry, with the m on it. And I could change this to a mixed number to be 1 3/5 m. So you can see that the 6/10 would reduce to 3/5 and be okay. So those are the same answer because they give me a true statement here at the end. All right. For the rest of that, go ahead and look at the independent practice there. See what you can do. Swimming pool, I would like you to look at that and come in with questions if you have them. You can email me with questions if you have them as well. In task 6, you will have some of these. So we pause the video and read it, but you know that P and Q, P is the 64 and 32 is the Q. But we always know that P is larger than Q. That is a given. Interpret each of them in terms of money and smartphones. So if we talk about P plus Q and 2Q, a lot of people will say, well, this is larger because if P is larger, then it has to be more than this because that's only 2 Qs and this is a bigger number. So here's how you're going to do this. Here's how you would get full credit. You are given that P is larger than Q. So if you can prove that in a statement, then you've proved whichever one you want to be larger. So for example, if you think this one's larger, then mathematically you write P plus Q is larger than 2Q. So we got to get to this statement to prove it. So 2Q is the same as Q plus Q. Now because of what we did in like task 1, you can take away Q and you know that that's going to be equivalent statements. So the Q's would go away here and you'd have P is larger than a Q. Since these match, that's true. That's what was given, that's true. Therefore, our hypothesis, what we put down first, is true. So if we get to a true statement, then that means P plus Q is larger. Okay. All right, let's go to the next one. And that's really all you need to do in order to get 100% on that. So for this one, again, we're given the same thing. P is larger than Q. So let's say, I think most of you know that this one is going to be the larger one. But let's say you thought that one was. Let's say that you thought the Q's were going to be the same, or the larger one. Well, you can do this a couple of ways. Combine these, so P plus 0.08P would be 1.08P, and this would be 1.08Q. And then divide by 1.08 would reduce that to 1 on both sides, so you'd have P is less than Q. So this is the given. We know that to be fact. With our hypothesis, this is proven to be fact. So because those contradict, then I messed up here. So what that means is this is a false statement, therefore this would be a true statement. So that is going to be the larger one. Now I know logically you can already get there. But just, that would give you full credit on the test. Okay, do some more of those. See if you need help with common questions if you do. Same thing here. This is the same type of task. You can do it the same way. It's just changing the letters. X is less than Y. Okay, independent practice for each pair of expressions below without substituting in specific values. Without. Determine which of the expression in the pairs is larger. So you can do the same thing here. You just can't put in numbers for it. So if you think about a T, let's say that you thought that was larger, right? Now this is a little bit different because nothing goes together over here easily. So you could combine like terms. So let's say if I subtract 5, I would get t squared is greater than -2 minus t squared. Okay, and then if I got the t's together by adding, I would get 2t squared is greater than -2. And to solve that one, I would divide by 2 and get -1. Now to solve for t, I would take the square root of both sides. with the plus or minus in front when you square it. So this would just become this. Now this is non-existent. You cannot take the square root of a negative 1. You cannot take the square root of a negative number. So this, it's false. So that means that that is false. So that one can't be larger. Okay. Now, think about if you tried the other way. If you tried this way, what would happen? Oh, sorry, that's the same way. What would happen? All these steps would essentially be the same, except when I get down to here, I would have t squared is less than negative 1. Is that going to change anything? No, because I still can't take the square root, so this is false. So what does that mean? Well, think about the numbers that would work here. Okay, now if you think about the numbers that would work there, if you have a 5 plus a t squared and a 3 minus t squared, is there a way to determine when one is larger than the other? So try to figure that out. Think it through. See if there's a time where this could be a number where this would be larger or smaller than this. When could you determine that? And we'll talk about that in class. And if you're not here for class, let me know if you have any questions. Okay. All right, sidewalk patterns is essentially same thing we were doing. Look over those. We spent some time on that. Make sure you can do those. All right, these task 9, you will have some of them as well. So on these, you can just use your algebraic expressions simplification. So here, you would distribute a 1. So you'd have a plus 3 minus b. Then you'd have a plus 3 minus b. Is that the same thing? Absolutely. Looks the same. Here, this is a big one that most people miss. If you have this, a minus b squared is a minus b times a minus b, because there's 2 of them. So when you do 2 of them like that, and it's 2 binomials, you would distribute the a to get a squared. A times negative b is negative ab. Negative b times a is negative ba. And negative b times negative b is positive b squared. These right here, even though they're switched around, they're the same, because multiplication is commutative. You can move them around. That is what that side would equal to. That does not equal this. Okay, so go through there and make sure. So this would be equivalent. This is not. Okay. All right. Look at those for homework. Let me know if you have questions. There's some more tile stuff that you can look at. Don't worry about that. Distributive property using area. This is something I would like you to look at as well. Area is the length times width. So you do 4 times 5. And 4 times 5 would be 20. Okay. This would be 7 times m would be your area. Find the area of each box in the pair. So this area would be x times 4, and this area would be 4 times x, or 4 times 3. And I would add those together in order to get the total area of those. Okay. What that is leading to is this. Instead of doing 2 boxes how up here they're separated. So up here when I did, like on this one, this area would be 7A and this area would be 7 times 9, which is 63. Down here, they're pushing them together already and saying just find the area of the box. So you could do it the way that we just did it. 5 times x would be 5x, and 5 times 7 would be 35. So that's the area of the sum. That's what it means by that. Areas of product would mean, well, this is the length, which is x plus 7, and this is the width, which is 5. So that's how they got that, but if you distribute this, you would still get 5x plus 35. So look at those, make sure you can do those. You will have some of those as well. Okay. Again, this is distributing. We simplified, sketched, and simplified. So you probably won't have any where you have to sketch those. But again, decide if they're equivalent just by doing some algebra. Okay, and that is it for that module. So if you have any questions, let me know.